Alrighty, so my name is Aanu Jibodu. I am a solution engineer at Teradata, and today we're going to be doing a demo with purpose to democratize access to data with LangChain and LLMs. So if you stick around, you'll see exactly what we mean by that.
Hi, and I'm Jack Lauritsen. I'm a principal engineer with Teradata, responsible for some of the backend that we have announced today. More on that later.
Okay, all right, I'll try to speak up as well. So we already did an intro. Again, I'm Aanu, solution engineer. So I work at Teradata in our new logos department. So I do a lot of demos, helping prospects understand like exactly what Teradata offers, what our solutions are, as well as how we can like integrate that. Oh, and then some fun facts, because we were asked to do this. I really like to read and write. And as I thought of that, I thought it was pretty cool that I'm doing a demo on natural language because my hobbies are around language in general.
Jeeps, cooking, all things cloud native.
Right, so we have one slide on Vantage Cloud Lake. So this is sort of our flagship product. It's our Lakehouse deployment. It's of course cloud native, so all the benefits of being cloud native, as well as like the strength of our Vantage engine. So Teradata has been around for, I believe, like 45 years, and we've gotten really, really good at optimization, at creating like a really powerful engine that like sweats the compute. So again, this is our Lakehouse deployment. And then we also have a little spiel on ClearScape Analytics, which I'll explain in just a moment. So I'll pass it back to Jack to share about very exciting product update.
Yeah, so I'll try to keep this a little short and painless for y'all. We had an announcement today showcasing a new product. Usually when I talk to customers about Teradata, the ones that we have are super excited about all the features and things that we can do, all the Gen AI things that have been built in for years before this huge boom has happened. And when I talk to people that aren't our customers, they've never heard of us. Largely that's because it's not that easy to get onto one of our systems. There are barriers when you're at enterprise scale. So we've come up with a new way of running this, which includes stripping away any of the managed storage. Everything is completely separated from compute and storage. We're only working on object store in this space. You'll be able to go to Microsoft Fabric and deploy one of these systems directly or through one of our marketplace offerings and deploy from your own Jupyter term or notebook and create a 1, 10, 100 node cluster, 1,000 node cluster at whatever scale you want. Work directly against your data. And when you're done building your model, a model that will still work in other Teradata systems or coming up with your query sets, you can suspend it and it will actually destroy everything that's attached. All of your schema changes will be recorded so that if you want to redeploy after lunch, it'll come right back up, remember where you were at, or get hashed to a different version so you can work on yesterday's data and you can continue. I think this will be a really exciting way for people that have never tried Teradata to get immediate access to it, to get it at a low or no cost, and to still be able to scale it to massive scales. Aanu, back to you.
Awesome. So next, we're going to talk a little bit about our ClearScape Analytics experience. So ClearScape Analytics experience is like a hands-on demo environment for you to try out Teradata Vantage. So you can, I guess, use the QR code or just type in clearscape.teradata.com into your browser to access the space. It's a really, really cool environment. So it works off of Jupyter notebooks. We have over 80 demo use cases that span different industries and like different analytic patterns. So I'd highly recommend. It's 100% free again, and it gives you the ability to like interact with our engine in real time with real data. You can even upload your own data and play around with it. So highly recommend, and you'll see exactly what this looks like in a second when we actually demo. I'll give a second in case anybody wants to use that QR code. But otherwise, we will head into our demo content. Just really quickly, if I haven't belabored the point enough, this is what our ClearScape Analytics experience looks like. So this is my environment. And then I can just click this button, run demos using Jupyter Notebook. But otherwise, we will head into our demo. So today we are going to be discussing generative question answering using generative AI with Teradata Vantage. Now that is a very long title, but basically what that boils down to is we're going to create an engine in which we can ask questions in natural language and get responses from our engine also in natural language. So how this differs from like a chat GPT is we're going to leverage this really powerful library called LangChain so that we are able to like use our own data and ask questions on top of our data sets. So that's sort of the what of what we're going to be doing. I want to explain like why this is. Obviously, Gen AI, generative question answering, has really, really blown up, even in the world of enterprise. Excuse me. And the reason why this is because of how powerful it is and the implications of this sort of technology. So I want to paint the why with a picture, a use case, if you will. The use case is actually going to match the use case that we're going to go through in this demo. So let's say we are a marketing department. We have tons of data as a marketing department. So we're running campaigns constantly. We're doing A/B testing. We want to see what is resonating with our customers. We need to act really quickly. So a whole lot of data, and there's a need to be able to analyze that data really, really quickly and gain insights from that data really, really quickly. However, we are limited in our ability to do so because, again, we are non-technical marketers. So we rely on like our business analysts and our data analysts to, number one, generate queries for us. So these analysts have to have like a pretty good understanding of our data in the first place. They need to be able to create queries on top of our data, sometimes really complex queries. And then they need to be able to translate the output of those queries into some sort of communication. So whether that's like written communication, a BI visualization, they need to go through all those steps. And then again, we are a marketing department at a large enterprise, so a ton of data. So we don't need only one business analyst resource, we need several. So we need to be able to do this at scale. And that introduces a bottleneck because we don't have infinite analyst resource. So there's a really pressing need for us to be able to, again, like ask questions immediately and gain insights immediately. So that's the why, that's the relevancy of this use case. And now I will go a little bit into the how by defining just 3 key components or 3 key concepts that we'll leverage throughout this demo. So first is retrieval augmented generation. So this is this sort of like dual model framework where we have a retrieval model, which retrieves information from some data source. And then that serves as input into a generative model, which is then going to generate a response to some user query based on that input. LLMs, or large language models, I'm sure all of you have heard of these, but these are language models trained on tremendous amounts of user data. So lots of like text data from all sorts of like contexts are fed into it. So the model will learn like syntactical patterns, like grammar patterns and how people speak. And it can be used to generate human-like text responses. An example of this that I think is very common is like autocomplete. So predicting the next word to come in like a sequence of words given some context. All right, last concept is LangChain. So LangChain is a really powerful framework that we're going to be using in this demo. So LangChain basically allows us to expand the use of LLMs. That allows us to build applications on top of our language models. So a couple of use cases I'll note. Number one, like applying real-time data to our models, like real-time internet data. Another use case is creating like a decisioning framework. So if we want our model to be able to make decisions. And then another use case, which we'll actually go through in this example, is again, like providing our own data and being able to use that in conjunction with an LLM to get answers to our specific data sets. All right, so I'll scroll up a little bit just to provide a really high level diagram of like the engine that we're going to create today. So we start with the user, who is going to ask a question to our engine as a prompt. It's going to get pushed down into our script here. So LangChain is going to provide a lot of context to our language model, which is going to provide an output. This output will serve as input to another function, which will add some additional context to, again, this output, as well as some additional context is going to be fed into another language model, which will provide us a response in natural conversational language that's fed back to the end user. So that's kind of the scope of what we're going to be doing today. So let's go ahead and jump right in. First step is configuring the environment. For the sake of time, I actually already ran these. They take a second to run. But all we're doing here is installing a couple of packages and establishing like the versioning. Next thing we're going to do is run this code chunk, which is just importing some libraries into our environment. So some ones that I'll note are the Teradata ML library. So this is going to provide us with some like unique in-database functions that we'll use throughout our demo. We're importing SQL Alchemy, which is going to help us connect to our database, importing LangChain, as well as some other like standard analytic libraries. Right, so next we are going to connect to OpenAI and Vantage, which is our database engine. So I'm going to enter in my API key. I hope this does not share on my screen. Okay, perfect. All right, so I've actually already gone through the instructions of, I personally have gone through the instructions to get an API key. However, you can also follow like the instructions here if you'd like to create your own key. Now I'm going to establish a connection to our Vantage engine. So I will type in my credentials. So here, I'm actually using this create context in database function to help create that connection. Right, so now we have established our connections. We're going to pull data into our environment. So I'm going to run this here. This is within a stored procedure, but basically what I'm doing is reading data from some external object storage into our environment in the form of a view. So this is just a foreign table, which we're reading in our environment. That ran successfully. We'll also run a space report, which is another in-database function that Teradata offers. So we can see that we have our demo marketing campaign database loaded into our environment, as well as that one foreign table view. All right, next we're going to do some very light data exploration. We're just going to do a quick preview of our data. So again, to provide some context, we're a marketing department. The data that we're going to be working with in this particular demo is pertinent to our most recent campaign. So we have all sorts of information around our customers who are involved in the campaign. So we can see the preview here. We have lots of like demographic information, their marital status, education, where they're located. We have information related to their engagement with the campaign. So when they were contacted, the duration of contact, the campaign that they were involved with. And then we have information around their outcomes. Like if they purchased our product, I can actually see my screen roll. Okay, if they purchased our product, the frequency of purchase, as well as like payment method, things like that. We see that we have 11,000 customers in this particular campaign sample. All right, so now we have some familiarity with the data that we're working with. Let's go ahead and build our language model. So first, we are going to connect our databases to LangChain using SQL Alchemy. So SQL Alchemy is going to allow us to establish this connection regardless of like the SQL dialect that we're using. So whether that be Teradata SQL, which we do use, or like MySQL or Microsoft SQL, what have you. It's sort of dialect agnostic. And then the second part of this code chunk that I'll point to is this parse catalog function that we're defining here. So this is going to go through our data set within our database. And for every column, it's going to create in pipe delimited format a record. So it's creating like a data catalog of each column. And this is going to serve as input into another function that we'll see later on. It's going to help us to identify the column that has the answer to our user's query. Right, so next I'm going to define my language model. So here I'm using an OpenAI model, GPT 3.5 Turbo Instruct, which is just a bit newer than like the default version. We set this temperature parameter. Temperature refers to, excuse me, the degree of randomness that our model is going to output. So a higher temperature value closer to 1 is going to provide a more like varied response, which runs the risk of not making sense. And a lower temperature closer to 0 is going to provide a more like deterministic or focused response. So given our use case, we don't necessarily need a particularly creative response. We just want information around our customers. So we go with a lower temperature value. All right. Next, we are going to create this identify channel function. So this is going to take as input the user query. And the first thing we're going to do here is create what is called a prompt template. So a prompt template in LangChain is going to provide additional context or information to our LLM in terms of how to execute. So here, this prompt template is basically saying that we should search through our data catalog to identify where the information is stored that's going to be able to solve our user's query. So we take that prompt template as well as our LLM and we chain them in a LangChain. And then our output is going to be the data source. So where the data is located that will solve our user's query. So I'm going to run this Go chunk. All right, next we are defining this run query function. And this is going to take as input, or it's going to call our identify channel function from that last step. So given the appropriate channel, we're going to create an additional prompt template. So this prompt template has a ton of context, and I'll just point to a couple. Again, prompt templates can be used for a ton of things. So in this case, for example, we're telling our LLM exactly where to search for information. We provide some just information that our LLM should know. So for example, if somebody's asking about marketing, we point them to this particular marketing table. And then we also have some examples. So I'll point to this for example. So given this user query, this is the sort of SQL query that we would expect from our LLM. So we stuff a ton of context in here. And then once again, we chain that with our LLM, and it's going to provide us a response, which is going to be the answer to our user's query. So I'm going to run this Go chunk. Okay. And then that's basically it. The last thing that we're going to do is format the answer. So this is just formatting in Markdown. But before we actually head on to the next section, which is just trying a couple of queries, I want to point out that in a couple of minutes, we've built what should work as a question answering machine. So we should be able to now ask questions directly onto our data and get the correct response. So let's try a couple of examples. So this first query, how many married customers have purchased our product? Let's run this. While this is running, I'll just remind us of exactly what's going on the back end here. So we have our query, which is fed into our run query function. This is calling that identify channel function, which the output is serves as input to the run query function, which again provided a ton of context on how we want our LLM to execute, is going to provide us with a response. So we see here that about 2,500 married customers purchased the product within our campaign. Now, if we have any questions or doubts as to that, we can validate because we can see exactly the SQL query that was run by our, or that was generated and executed by our LLM. All right, let's try another question. So what is the number of purchases made by customers who are in management professions? So we'll run that. Okay, and once again, we get an output. So we can see the exact SQL query that was generated, the SQL response, as well as how that was translated into natural language. Let's try a little bit of a more open-ended query now. So what are the most common purchasing behaviors of customers? Right, so we can see the thinking of our LLM here. So what are the most common purchasing behaviors of customers? Our LLM thought that was referring to purchase frequency. Whether or not that's correct is sort of up to interpretation. But if this isn't the output that we would have wanted, it would be up to us to sort of go back and create like a better question, right? Like I think this is a really vague question that we're asking. Or we could add prompt context within the prompt template. All right, so that's it. That's the end of our demo. I guess the next code chunk is just asking some of our own questions. So I'll open it up to the audience in case anybody has. Sure.
Does it work with unstructured data or is it only with structured?
So I believe it works with structured data. Adam, I'm not sure if you know the answer to that one. Yeah.
Yeah, so the question was whether it works with unstructured data. So specifically for Teradata, it can, because Teradata can do unstructured data in object storage. But technically, anything that is available to your database or in general, your analytical engine, that solution will work because there's nothing Teradata specific in it. The only thing Teradata specific is that in one of the prompts you saw that we said generate Teradata SQL dialect. Yeah, so anything your analytical engine can access, the solution will be able to support. So like if you do like Spark SQL, it will work very well with unstructured.
So is it guaranteed to be correct with no hallucinations?
No. No, it's not.
So I'm assuming this is running on your server, right? Through the web protocol there, right? This is not running on your laptop. You're running this query in this, and so this is running on a Teradata system, right?
You're right.
So what's the cost of the system that produced this answer in that amount of time, and what's the size of the data set?
Hi, I'm Adam. I'm awesome. Thank you. So the cost of the solution, so we're doing, so the biggest cost is actually not Teradata because, I mean, you could substitute Teradata with any other database and it's just retrieval to do RAG against OpenAI, really. So we're doing 3 OpenAI calls. So I don't know what the current rate is, but it's going to be probably in tens of cents, I guess.
Oh, question in the back.
Yeah, I want to know that how large is the data set you use to train the model to generate the SQL there?
Yeah, so actually there's no training at all. It's just pure RAG, and we are relying on what OpenAPI can do with a little bit of prompt engineering that you saw in those stages. So yeah, no training at all.
Have you guys tried testing this with Code Llama, or did you guys see any performance difference between what OpenAI does versus like Code Llama?
Yeah, so we did not try Llama, but we tried Hugging Face, and it wasn't there. No, actually, OpenAPI was the only one that was able to generate a valid SQL for Teradata. Now, your mileage may vary with some other databases who are where documentation and examples are more numerous on the internet. So I don't know, if you do something like MySQL, you may have better results with some other large language models. But yeah, based on what we've seen, there's nothing that matches what OpenAI can do.
Thanks for the demo. I have a question. How do you ensure that those SQL statements actually works? Is that possible that your prompt actually generated some SQL statement that totally does not make any sense?
Yes, it is possible. We haven't seen any like syntactical issues for Teradata. OpenAPI has been amazing with generating those statements, but we've seen not for this data set, but I tried it out with a different data set. And for example, my data set had historical data that went 2 years back. And when I tried to ask it questions without any prompt engineering, so the model did not know that there was only 2 years of history, it generated SQL that led to incorrect results. So it's, yeah, we're not doing any validation. This is a very trivial example. The awesome results that you're seeing is it's mostly OpenAPI magic, really.
A follow-up question for that. So how important for that prompt engineering for those texts? Those texts in the demo seems very natural, right? But is that just a one shot, or you have to do a lot of debug there?
There was quite a bit of tweaking. I mean, the prompts are not large, and obviously they cannot be large, right? Because you will hit the token limit of OpenAPI. But yeah, it wasn't like our first try. No, we had to add additional insights, examples to make it work.
What would you say to people who are petrified by the idea that you're letting an LLM generate a SQL query and immediately running it regardless of what is actually in it?
Yeah, we wouldn't do it in production. So one of the things that we discussed before the meetup, like we were going to ask you to tell us what question we should ask the model. And we were like, hey, it's going to be a smart bunch of people. What if somebody says delete database? And it is real. Like we don't have any constraints here. So yeah, I mean, it's a very trivial example.
So not drop tables, but what is the plan when OpenAI starts charging you for producing output in Teradata format? You know they're going to do it.
No, we already pay them for this. So,
right, but have you considered using other, open source models, for example? I know you said the performance is not there yet, right? But ostensibly, you could train the open source models with your
Yeah. So we haven't done like an exhaustive evaluation of all LLMs. Like I mentioned, we tried Hugging Face, and there was one more that we tried, but it didn't fit our demo environment. So it was just too large. Yeah. So I would say, yeah, there's your concern about the cost of OpenAPI calls is very valid. My bigger concern when I was thinking about this example is how much insights we would share with OpenAPI in those API calls, right? That was my main driver. And there are companies out there who are trying to solve exactly for this issue.
Could this be done over any other database? Like, I'm trying to understand, like, you're saying like much of the value is coming from OpenAI here. So what is the differentiator from Teradata in this whole example?
Yeah, so I mean, it's a meetup. So we wanted to give you something that is useful even if you don't use Teradata. So that was the main aspect. I mean, we use some of the Teradata features. One of them is ability to load data from object storage and basically deal with massive amounts of data once SQL is generated. And then we probably also benefit quite a bit from analytical, basically full ANSI compliance of the Teradata SQL engine. But other than that, this example is not Teradata specific.
Do we have any other questions? Okay, maybe the last one.
Thank you. So I'm wondering, so you're doing queries on the database. What if I wanted to do like some sort of data science, correlating this column with this column, or more sophisticated machine learning type analyses?
Yeah. So for example, Teradata is capable of doing that in SQL, but I don't know how well OpenAI would be able to support those queries. In theory, I think it's possible because this functionality is well documented, so it should be within reach of a good large language model. But yeah, I don't have any data points to tell you that it's going to work for sure. And then it works as a RAG, or how does it influence the result?
We'll have some time for more like discussions and all that later. Then, anyways, we have our second speaker, Kartik with Symbol AI. Do you want to share your screen? Thank you so much, Aanu. Thank you.
Okay. Hey, folks. Hopefully you can hear me out in the back. All right. Actually, all right. So I'm Kartik. I work for Symbol AI. We are a conversational AI company. And today I'm going to talk to you about LLMs for human conversation. This is not altruistic. We have an LLM that we're trying to sell, which is why I'm talking to you about it, which is also why I picked on Adam, who is awesome. Thank you, Adam, for playing along. And really, if you're going to leave my talk with one thought, I want you to leave it with this, that OpenAI is not the only option for you out there, right? I know it seems like it is, but there is an entire ecosystem of LLMs. I know there are performance considerations, there are quality considerations, all kinds of other things. But in this very short talk, I'll try to take you through some of them. I'll show you a demo of our language model. And I'll also take you through some considerations that, talking to customers, talking to our clients, talking to prospects, we've kind of figured out what is important to companies, what's important to small companies, large companies, what are the kinds of decisions that they go through when they try to choose an LLM. There's a barcode here for the people in the back. There are screens on the side of the wall as well. If you want to talk to me later, you want to connect, feel free to snap a picture of that. I have liberally put barcodes all over my slides. So wherever there's a source, feel free to take a picture of it. You don't have to take a picture of me, take a picture of the barcode. All right, so yeah, I think I have about 20 minutes. Let's get on with it. Let's see. Okay, I thought we would start with a game. I think all of you know what this game is. I think most of you have seen it. So I'm calling this game, Come Talk to Me If You Have. Okay, so after this talk, come talk to me if you have. Let's see, this doesn't seem to work. If you have questions, obviously, come talk to me, right? But yeah, questions, everybody has questions, right? We had a lot of questions. Come talk to me if you have strong opinions. Strong opinions are actually more welcome than questions. We value them at Symbol. We're a small company, but trust me, when we get onto those Zoom calls, a lot of strong opinions flying around. If you have use cases, right? If you have business use cases for large language models, I think the Teradata folks were talking about one very large use case, retrieval augmented generation, but there are lots of different use cases for language models. Come talk to me if you have use cases. Come talk to me if you have AI ML skills. That's something that is in short supply and very high demand these days. I'll go on a little later in the talk. We are hiring for internships and other positions. So come talk to me if you are looking and have those skills. Come talk to me if you can give us introductions to customers. I know this is a very eclectic and diverse crowd here. So again, if you know somebody who wants to use LLMs, please introduce them to us. Anybody want to guess what number one up there is going to be? Anyone? Yeah, come talk to me if you have money. Yeah, please come talk to me. Come talk to all of us. Anybody in this room, right? If you have money or if you have friends with fat pockets, please come talk to me. In fact, I'll end my talk right here if you have money for me. So as an incentive for you. All right. Okay, let's, jokes apart, let's get to the slightly technical part of the talk. I'll try not to make this talk very technical. There's not a whole lot of code in the talk, at least. Okay, 2 parts for the talk. I'll probably have to rush through some part of it. We'll find out which one. Part 1, I'm going to talk about a very, very short history of conversational AI systems. LLMs are, of course, only the last part of this story. There's a lot of stuff that's happened over the past 60, 70, 80 years, whatever you want to call it. And then part 2, I will talk about the real world. So things like consequences and money and other things. And what do companies look for when they make these decisions with respect to LLMs. And hopefully I'll have time to do a little bit of a demo of our LLM as well, our large language model, and show you what that looks like. Okay. Here is a interesting picture. As you can see, it's clearly not from very recent times. This is a picture from the 80s. And so the 80s were when the previous AI boom, or the previous AI summer, as people like to call it, was going on. And the interesting thing here that I want you to see is the breakdown of product areas, right? Back in 82, 83, 84, what did people think were actually going to be interesting areas that AI was going to focus on? I don't think we've gone too far beyond that. So when you talk about hype, right, remember, we are not in a unique point in time. This hype has happened before. It's just that now instead of billions, we're talking in the trillions. OpenAI wants to take over the world, but it's the same hype. Okay, here is a brief history of conversational AI. This, by the way, is from a great tutorial, which unfortunately you cannot see because of because of that little window over there, but that's fine. I don't know how to move that window, but that's fine. So there is a nice talk, there's a nice tutorial that has this picture. And of course, the interesting thing that you want to look at over here is starting from the 60s. I think a lot of people have heard about Eliza, which was the first quote unquote intelligent chatbot. I think some of you may have played with Eliza as well. There are lots of Eliza implementations out on the internet now as well. And Eliza really was a pattern-based system or a rule-based system. People thought that they glimpsed real intelligence with Eliza. Then we kind of moved on to the era of rule-based systems, then rules plus machine learning techniques. So you had everything like, Siri and the Google Assistant and Alexa and a whole bunch of other. This is the part of the talk, by the way, when I'm giving this at home, a whole bunch of devices wake up suddenly. To be really careful with this. I'm very happy this didn't happen with this audience. And then, of course, 2020, 2021 was when the era of the Transformers started, right? So everyone in this room has heard of Transformers. Maybe some of you have played with Transformers. Maybe some of you have built Transformers of your own. And that's really where we are now, right? That's what started this whole exponential increase that you see in this curve. And again, this slide is already old. It's about 2 years old at this point. And we're not talking anymore in the billions of parameters. We're talking in the trillions of parameters at this point. So that's a little bit of a history of conversational AI. Forgive me, I used to be an academic. I used to publish papers. This is second nature. I just have to explain things. One thing that I do want to point out when you go home, is this great article in the Guardian newspaper. It's a fairly long article about Joe Weizenbaum, who was the guy who actually wrote Eliza. And it's a technical article, but it's also a really philosophical article about what artificial intelligence means and what the dawn of this new era means. So really encourage everybody to read that. I found it really interesting. What do all these conversation systems mean in the real world? We've seen production level systems since more or less the 80s, right? So you had the systems where you could call a phone and it would do keyword spotting for you when it was trying to, do tech support for you, for example. Then we kind of moved on to intent determination. So you didn't have to exactly say the word that the system was looking for. You could kind of give it a jumbled paragraph that you were trying to talk about, and it would try to understand what you were trying to do, and then everybody, of course, hits 0 at the end of that. And then, of course, now we're in the era of all of these smart assistants and so on. But this is what it looks like on the consumer side, right? All of these techniques that I talked about, that's what it looks like on the consumer side. And what does it look like on the research side of things, right? Because a lot of the transformer era, a lot of the deep learning, a lot of the large language model era, it's been really driven by advances in research, right? So AI research, ML research, deep learning research. So here's a nice timeline, again, from this great tutorial called Deeper Conversational AI that came out in NeurIPS a couple of years back. I have the sources all at the bottom of my slides. Again, the barcode is unfortunately blocked off. And so this will give you an idea of how people started really scaling up these machine learning models to start dealing with specifically conversational use cases, right? So I'm going to talk mostly about conversational AI in this talk. So, you had these things called recurrent neural networks. Then somebody decided, okay, you know what? I can start stacking RNNs on top of each other. I can start making hierarchical neural networks. And so that'll give me, a jump. And then there was, of course, doing this training end to end, right? So you had a bunch of input that came in, you trained the system end to end, and then you hope for the best, which is kind of what we're still doing now. And then you had things like transformers that came in, right? So you had GPT, GPT-2, 3, 4, and so on and so forth. And really the reason that I am choosing to talk about this will be very evident to you, is this is a paper I worked on. So this is some free publicity for me. But this multi-resolution neural network is something that we actually worked on. I promise this is the most technical slide you will see in this talk. I don't even think I can explain this slide anymore. It's been 6 years, so don't ask me. But the crux of this basically is, instead of having a single network, what if you copy pasted 2 copies of that network, right? So you have one network that deals with the full natural language, and then a second network that deals with a coarse representation, right? So what does that look like? Let me give you an example of that. And again, for the people in the back, I apologize, but maybe the text is a little clearer on that screen over there. The idea here, and again, we were trying to do this for technical support, right? Tech support for Ubuntu, right? And the idea is, instead of just having these natural language sentences, if you have the sentences as well as a higher level representation, right? Just look at the nouns and the verbs in those sentences. Your network actually learns a lot more in terms of trying to debug this problem, in terms of trying to solve this problem. And the reason that I'm talking about this is this solves one of the big problems that we still have today with large language models, which is the outputs are great, they're very creative, right? But they're not very specific. So if you're trying to solve a very specific task, right, it doesn't get you much further than a certain baseline level, right? Which is why you have to do things like retrieval augmented generation and a whole bunch of other things. Because if you as a business, you as a user of large language models, want that model to produce output that is specific to your use case, specific to your customers, they're not there yet. You have to do all sorts of things to make it do that. So anyway, this was something that we started working on. At this point, I think it's been 6 years, 7 years. And this continues today. So the language model I'm going to talk to you about today, the large language model called Nebula, we do similar things in order to make it produce specific output for business use cases, okay? And I'll come to that in the rest of my talk. Okay, so that is as far as I'm going to go in terms of giving you a bit of an overview of the history of conversational AI and some of the background and so on. What does this look like for the real world, right? What does this look like for businesses that are trying to adopt large language models? So this is a graphic that I came up with, and it's something that I think is kind of useful to think about. And again, this is based off of all of the conversations with our customers and with our people who have money. And basically, it's this idea of 2 different worlds of LLMs, right? So on the left-hand side, you have world number 1, which is kind of like this smaller ecosystem of startups and open source models and everything, right? And on the right-hand side, you have world number 2, which is more of, the very large companies, let's say, right? So OpenAI, Amazon, Microsoft. I don't know if I can say this in GitHub. Probably I can. But anyway, and there are differences between these 2 worlds, right? One, of course, is the cost, right? So you can kind of customize the cost of using a model more easily if you're using, let's say an open source model, or if you're using a smaller model, right? There's also things like incumbency, right? So what we've found talking to customers is a lot of people especially if they're going to put your LLM into production use, right? They want to know, you as a company, did you just open shop 2 months back because everyone's talking about LLMs, or do you actually have experience in the domain that you're talking about, right? So that's what I really mean by incumbency. Do you know the domain and the use cases inside out, right? And that's something that's really important to a lot of customers. Another thing that's important, this notion of support, right? And by support, I don't mean just being able to get onto the phone and saying that, hey, your model's not working for me, or your endpoint is down, or whatever, right? I also mean things like model iteration, right? How many people have built something on OpenAI, right? And then they switch something in their model and your cool demo or your cool product or your cool company just stopped working, right? And so these are things that large model providers can and absolutely will do, right? OpenAI is not trying to keep your company afloat. They're not trying to keep your demo afloat, right? They will absolutely change things on you. They will change model parameters on you. There's also this notion of fine tuning, right? So if you have a specific set of data and you want to fine tune a model to produce behavior that reflects that data, you want to be able to do that. There's also this question of deployment flexibility, right? So most models today are on the cloud, right? They're fully managed. So you have to make a call out to, let's say, OpenAI or to, I don't know, Claude or any of these other models. But what's increasingly important to a lot of customers is the notion of an on-prem availability for large language models, right? Can you deliver them models that they don't have to send their data out over the open internet, right? I can't tell you the number of clients that we talk to who say, hey, this is cool, but I'm in Europe, right? And I can't go against GDPR. My customers have these requirements. I'm in, APAC, I'm in the Middle East, right? And we have very specific rules about whether data can come out. And so it's important to offer those kinds of flexible options. Data reuse, right? Anything that you're sending OpenAI today, yeah, you can kiss that data goodbye. You don't know what's going to happen to that data. Well, right? It's going to come out in the next iteration of their model. But a lot of people are very careful about this because remember, companies' data is not their data, it's their customers' data, right? And they can get into all sorts of legal issues with this. And of course, this notion, I think this came up in a question as well, this notion of hallucination and guardrails, right? So can you empower your large language model to say no? And spoiler alert, the answer to that is no today. But then can you put guardrails on top of it so that when it does hallucinate, you can actually control the output of the model? So these are all, I think, important things to keep in mind. And then, this is just, I'm a big XKCD nerd. I have to flash this comic every time I talk about one of these things. This was true 15 years back. It's true today. Nobody really knows what the hell is going on, right? We put in a bunch of data, we get out a bunch of text, and somehow that's intelligence, right? That's basically what we're all doing even now. Okay, let me talk very quickly. I have just a few minutes left. Let me talk very quickly about my company and about our language model. So this here is a diagram that shows you the Symbol AI platform. So Symbol AI is the company that I work for. We are a conversational intelligence company. We've been doing this for more than 5 years now. So we have the incumbency in the space that I was talking about. And the essential part of this that I want you to focus on, right, is there's 3 parts here. There's the input, there's the models, and then there's the output, right? And so with respect to input, obviously, we've been dealing with all sorts of multimodal input, right? Because conversations don't just arrive as text. They usually start as audio, they start as video, right? And you want to be able to process that. Now, the nice thing is because we've built this developer platform over the past 5 years, we have over 50K developers using our platform. We were actually named one of the top 25 APIs by Postman anywhere in the world, right? So we're up there with the Slacks and the Salesforces of this world. We've managed to basically gather a very large proprietary data set, right? Of course, with permissions, with everyone's consent. And that is a big differentiator for our model, right? When we say we are an LLM for conversational data, for communication data, we actually mean that, right? What we mean by that is we've basically put together a whole bunch of data that we use when we're training our model. And here's a very high-level overview of what that data looks like, right? When I say communication data, when I say conversational use cases, this is really what I mean, right? And so conversational tasks, this should be obvious to all of you, right? These are the kinds of things we try to do when we try to process conversations, when we try to analyze conversations. We want a summary of the conversation. We want, action items from that. We want to extract entities. We want to do all sorts of fun things with it. And then what does communication data look like? It looks like all these different things, right? It's not just enterprise data. Of course, that's a big part of it. Sales calls, customer support, contact center, and so on. but also a whole bunch of other things, right? Zoom calls, webinars, YouTube videos, podcasts, media. All of this is communication. All of this is humans talking to each other and so on, right? So this is basically a very, very high level overview of some of the data that our model is trained on that I can guarantee you OpenAI, GPT 2, 3, 4 does not have access to, right? And so that's a big difference in terms of the models. So yeah, this is it. Nebula, that's our large language model. Very quickly, I think I've already talked about some of this. Trained for multi-party human conversation understanding, created for conversational tasks, specialized with all forms of different kinds of communication data. Also multilingual out of the box. There finally is a barcode that I talked about. I spent so much time creating these QR codes, and half of them are not even displayed. It's just sad. But anyway, if you click on that, if you focus on that QR code, it will take you to the sign up website for the Nebula model. So we are still in private beta. We are going to come out into public beta very soon, and then we'll be in GA probably early next year. So if you want to get on the wait list, if you want to get access to the model, that is where you go and sign up. And like I said, if you bring customers, if you bring money, it's more likely that you'll get in faster. Wasn't kidding about that. Anyway, so here are some quick results of the model itself. Obviously, like any good model provider, we made our evaluations against, well, this is GPT 3.5 Turbo, but we're running evaluations now against GPT-4 as well, because that's the latest model that's come out, and GPT-4 Turbo, which was just announced this last week. And you can see that, I wouldn't be showing you this if we didn't beat GPT on some category, right? So clearly, we do beat GPT on different kinds of accuracy metrics, Rouge 2 score, BERT F1 score, some of the summarization metrics and so on, right? I mean, one thing I have to be really clear about is if somebody tries to sell you that their model is better than another model because there's a 0.005 difference on some accuracy metric that only a researcher has heard of, they're trying to sell you a bridge, right? All you're looking for is the performance somewhere in the ballpark, right? The 0.005, you don't know what that means. Nobody can tell you in a quantified way what that really means. But here I am trying to do it. Yeah, we have some other metrics that deal with bias as well, because obviously that's an important part of these models. We've also evaluated the model against other models. So one of the nefarious things about the whole LLM space is nobody really releases the code, especially for proprietary models, right? And so you kind of have to benchmark. You have to trust people's numbers in some sense, right? That's a great way to do business, just trust people. Anyway, here are some numbers. Again, I did include GPT-4 on these slides, being very intellectually honest here. And you can see that GPT-4 right now is way better than most of the other models out there, but it's also way bigger and way more expensive, right? It's an order of magnitude bigger. It's a trillion parameters, right? Another popular data set, the AI2 reasoning challenge, out of AI2 here in Seattle, by the way. AI2 reasoning challenge, also we're competitive on these numbers. Final thing, in addition to the language model, we also have an embedding model. All the people who know what RAG is are nodding their heads right now. So you need an embedding model in order to do things like retrieval augmented generation and so on, right? So we do offer a Nebula embedding model. Again, the advantage is that it has seen a lot of conversational data, a lot of proprietary data that every other model out there has not had access to. And so if you have conversational workloads, if you have use cases that depend on communication data, this is what you want to be using. And then just a quick point about multilinguality, because this is something that's becoming important. A lot of people want language models to be able to handle multilingual use cases. I actually wrote a blog post about this. Thankfully, that's one of the QR codes that shows up. You can find the blog post over there, but here are some graphics from it. And really the takeaway that I want you to take from this is tokenizers, and hence the cost of using a model, right, is not uniform across languages, right? It is not language agnostic. Because anybody who's paid for the use of a language model knows that you're billed by the use of tokens, right? Input tokens, output tokens. But the same text, literally the same text, in, let's say, English, versus if you were trying it in some other language, let's say Hindi, right? That can cost you, I don't know, 5x or 10x, right? For the exact same text. And that's a non-trivial point, right? And that's something that it really shouldn't be the case, but it is, unfortunately, in today's world. So that's an interesting thing that you guys can read about. think I spoke about a bunch of this, through the talk, conversational challenges for large language models. Again, this is something that we're finding when we talk to our customers is that the numbers that I showed you, this is where my whole hypothesis of the numbers don't mean anything is coming from. Customers don't care about numbers beyond a point, right? What they care about is the output that your language model is giving me. Is it diverse? Is it consistent? Consistency is a huge deal, right? Because people are doing things with whatever the model produces afterwards, right? And if you can't give them somewhat deterministic output, that makes them very mad. And also things like empathy and controllability and versatility, all of these fun things that language models do. This is our roadmap, we're trying to add things like multimodality and obviously increase the size of the context windows and so on. Okay, let me see if I can do a really quick demo in a minute, and then I will hand over the mic. So here is our playground experience for the model. I'm going to try using this mic now. So this is basically the Nebula playground. We've built something on top of the model so that you don't actually have to write code when you're trying to play with the model. So obviously you can do things like summarize this conversation. That's just the most obvious thing that a language model should do. And this, by the way, is an instruct version of the model. We also have a chat version of the model that I'll show you guys. This one works better if you're trying to analyze conversations and things like that. Some of the cool things that you can do, extract the speakers in this conversation. So that's something that most language models should be able to do. But I can also say things like extract the topics in this conversation as JSON, let's say, right? And so now you start getting into more of, I think somebody had a question after the previous talk about, can you go from unstructured data to structured data, right? And so these are things now that a lot of people want because they want to be able to post-process the output afterwards, right? And they want to do things with that. All kinds of other fun use cases. Like I said, if you apply for access to the model, you will be able to, play with it. And then finally, this is the chat version of the same model. It's just a different experience. And you can chat with the agent. You can see here that, I was very nervously trying to prepare for the presentation. How do I make an engaging talk? Apparently, LLMs know how to do that as well. So, okay, let me go back to this. Let me end my talk. I know I'm getting a few dirty looks from the organizers. That's my last slide. What is on that slide? Yes, all 3 barcodes are visible. Fantastic. So the link on top, that is the link to apply for access to the Nebula model. And it'll give you all the other details about the model, what it's trained on, what it specializes in, what the differentiator is, and so on and so forth. And like I said, if there's one thing you take back from this talk, please take back the fact that OpenAI's models are not the only models available today that you can use. There are other equally good models, perhaps even better models out there, especially for specific use cases. In the case of our model, if you're trying to deal with conversational and communication use cases. We are looking for people with AI ML skills. I wasn't kidding about that. We are especially looking for research interns right now. So if you're looking for internship opportunities or people who are looking for internship opportunities, that will take you to the job posting. Please encourage people to apply. And that's me. I'm Kartik. Please send me a message if you want to talk. And thank you for your time.
Fascinating talk. Thank you very much. If you guys would hold your questions until after our 3rd tech talk, I want to respect his time. This is Sean from OpenCUI. And yeah, we'll have plenty of time for open discussion afterwards. Yeah, fascinating.
This is how you do it. Don't leave time for questions.
Sorry. Yeah, so my name is Sean, and I'm working on a sort of open source project on RAG implementation of function calling. How many people knows about OpenAI function calling APIs? How many people actually used OpenAI function calling APIs? Okay, so I guess I'll just trying to Oh. So trying to sort of make a case why function calling APIs is something that's interesting. So basically, like with all those sort of instruction-tuned large language models, you can think of it's a sort of an interpreter with natural language as instructions. So just like Python, you use like Python interpreter to do something. And like with prompt engineering, you can essentially use natural language to solve problems. There's two kinds of paradigm when you're trying to use language models with your existing sort of software or like, code. One way is you kind of use a large language model as an orchestration layer, and then you sort of supply the plugin to, let's say, ChatGPT. Another way is you manage the orchestration of your application logic, and then you use large language model for language understanding or function calling or that type of thing. Regardless which paradigm you choose, somewhere you have to turn the natural language sort of text into some sort of a structured data so that you can then process it. So before like open source, before OpenAI function calling, trying to turn the sort of the natural text into some structured data is a big issue. Like, everyone worked on the sort of chatbot in the past. You know that you need to sort of prepare the training data. You need to sort of do, intended classifications and slot filling and a list of sort of machine learning tasks that you have to go through before you can even sort of use it with the rest of your APIs. What OpenAI function calling does is essentially, instead of asking you to sort of use natural language to describe your functions or your APIs, it gives you additional, I don't know whether you can read it, but basically it gives you, in the completion API, it gives you additional parameters so that you can fill in a set of functions. And when user utterance hit one of those functions, open AI completion API will turn that into a structured representation and bottom. Unfortunately, it's kind of fonts are too small. So, but there's a couple issues with with the function calling API that provided by the OpenAI. The first one is they're not cheap, right? So also even though they sort of increase their context length size, if you have too many functions or many APIs that you want to sort of dispatch, then context length became an issue. And also those specification can count as tokens, so that could jack up the price. Another issue is, as with all those large language models, they make mistakes. Sometimes they can't get their functioning right, and sometimes they can extract the right parameters. Particularly if you have those sort of private entities that only sort of your sort of business use, like Starbucks use Tor as not Tor. So so those things are not, Starbucks is not an example, but like if you're a new company, the entities you define might not be in the language models, and then they will make mistakes. Lastly is sometimes users just don't say their intention in full, right? So instead of saying that I want 2 movie tickets for Star Wars at 8 o'clock. They might just say, I want 2 tickets. Then in those cases, you need to have a mechanism to essentially extract value, sort of engaging sort of conversation with user, and it gets the, extracts the value so that you can trigger your API. Under those cases, like you might have those reactive sort of utterances from user, like when bot asks you, like, what movie you want to watch, they might just say Star Wars, right? So you need to be able to sort of get those into the right slots. Those are the issues. And you can also ask questions about, like, do we really need to have this 100 billion parameter models for just doing the conversation from text to functional representation, right? What if you have a sort of a system that's in the production and then you have a new product out? Do you have to retrain it, right? Can you hotfix the understanding part? And finally, I just said that if in the conversations that the user reactive utterance need to be understood under the certain context, how do you do that, right? So with function calling API, you don't have those, you can't fix those things. So how do we solve those problems? How do we improve from there? So OpenAI function calling only use a function name and the description. So the first opportunity is we can try to use this so-called in-context learning. Essentially what it does is, in the prompt that you send to the completion API, in addition to the goals that you have, you also specify some sort of examples, like, for this particular sentence, that's the JSON representation of understanding or representation of that utterances. And this typically works, right? And the other opportunity is, like, what if you have like thousands of those examples? Like trying to put them into the context is expensive, and trying to sort of fine-tune the model every time you have a new sort of example is also not an option. So we can try and use what like everybody use nowadays, use RAG, right? Essentially, when user utterance comes in, you just do a quick search, figure out what is the closest example to those utterances, and then trying to include that in the prompt, and hopefully you can sort of the language model can do a better thing with those new added example. So the project is called LAG, stand for Language Understanding and Generation. It is a standard RAG implementation. Instead of just use function specifications, we define 2 additional pieces of evidence that you can feed into this RAG system. The first one is an utterance example. Essentially, like, in the old days that you're trying to train intended classification models. But with RAG, you don't need to have that many examples. And also, those examples are mainly designed so that you can hotfix things. So if you have a system running and one of the sort of new utterances that your system can't really sort of do it right, what you can do is you can essentially just code add that example into the RAG system and do a restart. Then your new model. Sorry, you did not train a model. So the new system should be able to understand those new utterances easily. And the other ones that you want to do is you can add a sort of a recognition mechanism for private entities. I'm gonna switch over to the GitHub page. So it's very easy. Open CUI. CUI stands for conversational user interface. So we kind of old school where we mainly trying to use language model to give developers the control instead of sort of a fit, focus on the model itself. So the function specification, we take OpenAI and the Open API format. You just supply a typical Open API functional specification to a model. It should already start to do something. If one of the user utterances that, say Llama 7B can't do it yet, what you can do is you can essentially add examples in form of, for each functions, you supply the templates that can, you deemed as the trigger phrase or trigger sentences for the corresponding functions. And finally, you can sort of give a list of entities or some reg expressions to the log so that it will be able to easily recognize your business specific entities. So so it's an open source project. I started like a while ago, but I only in recent like 4 or 5 weeks I've been working on it fully. Right now it's already sort of I have the entire thing in this particular address. You can this QR code actually linked to the GitHub repo. You can follow the README under the fine-tune directory and be able to go through your data set, and then you can use client to do the inference. And finally, thanks, that's my talk. And I'm writing quite a bit on media about conversational user interface, meaning that we assume that business want to have full control in terms of how users should access their APIs. Instead of content, we mainly focus on the API part. So we pay attention to how you turn the language into structured representation of functions. And then we also help you to build interaction logics easily so that you can cover whatever sort of business case